Here is another one of those building codes you might not be familiar with. As a matter of fact, I know most people I've met aren't familiar with it, including builders who think that you can install spiral staircases anywhere in a house. And that's not always going to be the case. There is a building code that says you're not allowed to use spiral stairs as the only means of egress to an area that is going to be larger than 250 square feet or 23 meters. And that area cannot serve more than 5 occupants. And don't forget to check with your local building codes. The information in this video might not apply to your area. And here's the building code reference number I'm talking about and the book that I got it from. And the last thing I want to point out is that a spiral stairway is not the same as a curved stairway or a winding stairway that can be used for egress or access to an entire upper level. This is a two-part video. The first part is going to explain how the building codes might impact your project when building a straight set of stairs. And in the second part, how those measurements might not be as accurate as you think they are on a set of building plans. In this video, I will provide you with a few things you need to think about when designing a straight stairway for a 2-story house. And the first thing on that list will be how much room you have. Will the stairway actually fit into the space based on your local building codes? And this would include using the maximum riser height and the minimum tread depth measurements. So the first thing I want you to do will be to figure out what those building codes are. And one of the more common building codes for a residential 2-story house will be a 10-inch minimum stair tread. However, yours might be 11 inches or it might even be 9 inches. And as far as the riser height goes, that's usually going to have a maximum of 7 3/4 inches. However, it might be 8 inches in your area or even shorter than 7 3/4 inches. So these are the two measurements you need to validate. Then you can do all of the necessary calculations to figure out how long the stairway is going to be and whether or not it will actually fit into the desired location on your building plans. Next up, let's go ahead and take a look at wall locations, floor heights, and again, more minimum or maximum building codes. There will usually be a minimum width between the front of your stairway and a wall or other parts of a building that will force you to either create a shorter stairway or relocate the walls. And most of the time, you're not going to be creating a smaller stairway. And this is a big problem for some of our viewers. They want to design a stairway that's going to fit into a particular space without using building codes that were created with your safety in mind. So if you have a situation where the only way you're going to be able to build a safer stairway, maybe even remodel an existing stairway to make it safer, then just keep in mind that the stairway is usually going to need to be longer. If it's a straight stairway, you can always turn it by putting some winders in or a landing. However, that could create problems for the headroom or the floor space above. And I will address that issue in another video. So in the real world, not the fantasy world, if you need a longer stairway and a minimum space between the front of the stairs and the wall located on the lower level, then you might need to move the wall back further. And this could create smaller rooms on the other side here, especially in an existing house. Or you're going to have to move the stairway, and in some cases, structural framing components and concrete footings in the opposite direction to make it work. And this video would not be complete without mentioning the second floor, the upper level floor, and the stairwell or the headroom height. There's also going to be a minimum measurement for your headroom height to prevent people who use the stairway from hitting their head on the ceiling. And this is probably the most overlooked design flaw made by do-it-yourselfers and even professionals. I can't tell you how many times I built a stairway with a headroom problem. And that's usually not where this problem ends. It's not uncommon to have a wall located over this section of the opening. And if you need to move that section of the opening back to increase the headroom height, then there's a good chance you're going to have to move this wall. And if you move this wall, you might have to move this wall. And in some cases, you will need to move the walls in the other direction. Again, this can create problems for the rooms that are either already small or cannot be shortened. Here is a problem that I had years ago and thought I would make you aware of it, and that is the fact that sometimes the measurements on a set of building plans might not be accurate. And if they are not accurate, or you have a small mistake where the building designer might have rounded a number off in their favor so that the plans could pass local building code inspections. And this usually happens when the architect doesn't have enough room to make the stairway longer and instead wants to remove one step so that it will fit into their particular design. And this usually will create problems that will need to be addressed during the design phase and not the construction phase. So pay attention. And let's go ahead and walk you through an example of one of these problems, where we're going to figure out the total rise so that we can figure out the individual riser height. And we can do that by adding up a few numbers. For example, to find the wall height, all we need to do is add the lower framing plate and the two upper framing plates together to get 4.5 inches, and then add our wall framing stud height of 92.25, 92 inches, to get a wall height of 96.75. Then we're going to increase the wall height by 1/4 inch because of variations in the lumber sizes and gaps in between the framing components. And then our joists are 7.5 inches, floor sheathing 3/4 inch. We're going to add those numbers together to the 97 inches to come up with 105 inches, or 8 foot 9 inches. Then to figure out the individual riser height for our stairway with 14 risers, we're simply going to divide 14 into 105 inches, and that gives us a 7.5, a 7.5 inch riser height, which would be acceptable for most building codes in buildings with less than 50 occupants. But if the minimum riser measurement is 8 inches, and the building designer thinks they can get away with 13 risers because when they divide 13 into 105 inches, they get 8.076 inches. And if they want to round that number off to the nearest inch, that's going to be 8 inches. And this is where the problem starts. And yes, I've had this happen to me plenty of times when I was building stairs for large tract home builders who needed to make these measurements work even when they didn't. Now, for those of you who understand enough about math, can figure out that if we multiply 0.076 times 13, we're going to end up with 0.98, or almost 1 inch. However, whether or not that would be a problem or not, I will leave it up to you. I just wanted to make you aware of it as a home builder, contractor, or someone who's going to be assembling the stairs for measurements that are on the plans, suggesting that the individual risers are too close to the maximum rise required by your local building codes. Check out some of these interesting stair designs. Something you might find in a country home. This is a follow-up video to a video that I made in 2019 about the folding carpenter rule. And this would be the tool that was eventually replaced by the measuring tape. And even though I don't think I would use a folding ruler, there are plenty of people who still do. In other words, in the world of laser measuring devices and digital levels, the carpenter's rule, or mason's ruler, as it would be known by masons, is still considered to be simple, reliable, and surprisingly versatile. It has been a constant companion for builders across cultures and generations. In other words, some of these tools have been passed down to them by their fathers or grandfathers. And according to some of the research I did, its origins can be traced back to ancient civilizations, where early versions were crafted from wood, ivory, and even bone. But it wasn't until the 18th and 19th centuries that the folding ruler truly came to its own. The Industrial Revolution brought about mass production and improved materials, making it an indispensable tool for carpenters, masons, and engineers. And if you're someone who would never even think about using a folding ruler, or somebody who is totally obsessed with using a folding ruler, feel free to share those stories with us in the comment area. And for those of you who need a little more information on how these folding rulers might be used, then stick around for the second part of the video. In this video, I am going to show you what they had before the tape measure was invented. There it is, a folding ruler. And the tape measure, I think, would be the instrument of choice for most carpenters today, but this is what they used back then. You just simply folded it out in sections, butted it up against the edge of your piece of lumber. You weren't going to be hooking over anything like a tape measure, and then making your mark. There it is at 10 inches. Now let's double check it with the tape measure there. Nice, right on the money. And the only thing I could see is from tip to tip, there was, I think some rulers were 7 inches. This was about 1/8 of an inch short. So you wouldn't be able to just take the section of the ruler and mark at one end and then mark the other end. That just wouldn't be happening. So there it is, folding ruler. If you flip it over, you have 1 through 72 inches on one side, and then you flip it over, and then you have the reverse on the other side. And this all makes sense. You're kind of thinking like, why would it be like that? But if you turn it over, you can see where it's 1 to 6 inches on each side. So that would help you if you were measuring something. You don't have to think about which side you're going to use. You can grab either side and start marking, of course. So the folding ruler there, and of course the tape measure there. And like I mentioned earlier in the video, I don't think I would ever use a folding ruler because I've been using a tape measure my whole life. And I think the same type of reasoning makes sense for those who have never used a tape measure and prefer to still use a folding ruler. Here is another one of these super awesome videos that I usually make. Well, sometimes I don't, but this one could actually be that for the right person. Now what I'm going to do is cut a regular stair stringer and use that as a pattern to lay out and mark the plywood that I'm going to use for my template. Now you don't need to do this. You can always lay out the plywood, and I do have other videos on that. And then after you have it laid out, you've double checked all your measurements. I know that's not what we're all going to do, but it always helps to double check all your measurements, especially if you're dealing with expensive lumber. And the lumber I'm using here is 1 1/8" plywood. I will not be able to provide you with the exact materials to use, and don't really know if this is something that would be approved by a structural engineer, which would probably bring up your next question: why did I make the video in the first place? And that's because I actually have seen it done before, and we'll leave it up to you as to whether or not you're going to use this idea or contact an engineer that will provide you with specifications for materials and assembly. So you can see where we're going to end up with a lot of waste here. However, for this project here, we're going to be able to get at least 2 pieces to assemble our stringer with out of 1 sheet. And keep in mind that this might not be the case for you because it's actually going to depend upon the design and the length of the stringer. And of course, the length of the landing. And if you need to position them a little further apart, then something like this might help. And of course, don't forget to get as creative as you need to be. Maybe you can actually get a few more of these stringer supports out of 1 sheet of plywood, or consider getting longer pieces of plywood if that will work for your project also. And next up, we are going to glue these pieces together. I would suggest being liberal with the glue. Do not be conservative. And if it was me, I would spread the adhesive on both of the sides that I'm going to be putting together. And of course, you would repeat this process if you were going to be installing more than 2 of them together. And if you have clamps, I would use them. clamp the heck out of these babies. And even though I only have 4 here, you're probably going to need a couple down here, 2 here, a couple here, and then a few over here. And you could always glue 2 of them together at a time and let them dry, and then attach the next one after the adhesive is dried. And you believe the previous ones are securely fastened together. Now you can always use nails or maybe even screws or even bolts if that will work better for your project. And then after that is done, you can go ahead and assemble this section of your stairway with a landing that just might not require any structural supports underneath this section of the stairway where we normally would have a wall or a beam. In this video, I will provide you with a tip that might be invaluable if you actually want to build a straight set of stairs with tires, or at least as close as you possibly can, because most of the tires you're going to get are going to be used for one, and they're probably not going to be the same size, but I don't think that's going to be that big of a deal using this method here. So let's go ahead and get started by placing the lower and upper tire, or the last step and the first step. This is pretty much key to making this work, and whether or not you need to figure out what the total rise and run is, I do have another video for that. I will put a link to that in the video description box. However, that might not be necessary if you have a slope on the hill less than 35 degrees. And of course, tires that are going to provide you with the correct riser height. So the first thing I want you to do is level the lower and the upper tire. I want you to do it in both directions, and you're going to use this method to set every single tire in your stairway. So after you have the first 2 tires situated, you can go ahead and drive a stake into the ground and try to position the stake to where the string that you're going to be using to attach to the stakes will be located in the same position for each tire, preferably in the center. So here we have a stake that's driven into the ground. We went ahead and put a nail or a screw on the side of it, and then did the same thing down here and got it as tight as we possibly could, or at least tight enough to create a straight line here. And this is what you're going to use to position the rest of the tires. You're not going to need to measure anything, because all you're going to be doing is setting the tires, each one of them, to where the front of the string will barely be touching the next tire or the next step above the lower one. So after you have this one set, your string's in place, go ahead and set the next tire. So this will obviously require some type of dirt removal. So you might need to remove the dirt in the back of the tire, fill the dirt in the front of the tire. And you can see here where we've positioned this one in the center. And if we go to the side, you can see where it's just barely touching the edge, front edge of the tire. And even though this will provide you with an approximate location for the front of the tire, the steps might be a little shorter or wider depending upon the diameter of the used tires. So I'd imagine something like this is going to work a little bit better if you can find tires that are going to be about the same size. But I still think it'll work if you get tires that are close enough. And again, you're just going to lay one after the other until you've completed it. And once you're happy with the location of the tires, you can go ahead and fill them with some type of a gravel, concrete, dirt, whatever you want. And now for the bad news, there's a very good chance these tires will not meet your local building codes. However, it might provide you with an inexpensive way to get from one point to another point on your property. In this video, I will be providing you with another method that might be easier for you to install skirt board on an existing stairway. And of course, a stairway that might not have the exact riser sizes or tread depth for each step. And I have definitely seen them on a variety of different stairways. And this really isn't that bad of a design. You could always fill the gaps if you didn't want to have gaps, maybe with some type of a sealant or a wood putty. And if you use a wood putty, there's a good chance it's going to crack. So if I was you and you didn't want to see these lines here, then you might consider using a different method. And you can start at either the top or the bottom, or you can start with the first tread. And that can be done at either the top or the bottom. And you can cut all of the pieces for either the horizontal or the vertical sections and then fill in these areas after you have cut and installed all of those. And hopefully that would end up looking something like this after it was completed. Now let's just say you want to start with the first trim board at the top. You could just simply butt it up against the wall or the end of the landing, or maybe it might be butting up against a piece of door trim, and then simply let it overhang a little further past our measuring board here. And that could end up looking something like this. And all you need to do, you guessed it, is simply mark it and then cut it. And I could always use this measuring board here and simply measure from this point to this point and then cut my piece of lumber. And if you're going to do something like that, you could probably grab a piece of paper or a scrap piece of wood and then do all the measuring you need for all of the horizontal pieces or vertical pieces if you're going to start with those. So if we're going to start with a horizontal, let's go ahead and start working our way down the stairway. I'm going to place my measuring board tight up against the face of the risers here and tight up against the wall. Grab my measuring tape and measure from here to here, or grab a piece of trim that's going to be a little bit longer. Then use my measuring board in the same way that I did up here, and then simply mark it and cut it. And again, the measuring board can be used to measure the lumber or to use it to actually mark the trim. And I'm not about to suggest that all of these cuts are going to be square. So you might need to cut a few extra boards if the boards aren't fitting correctly or maybe have a little larger gap than you might like. And I would suggest measuring from both ends here. Measure from this point down and from this point down here. Wouldn't be a bad idea to measure from this point over to here. And I wouldn't suggest permanently attaching the trim boards to the walls until you know everything is going to fit correctly. You can temporarily attach them to the walls, just don't permanently attach them to the walls, because these boards might need to be trimmed a little bit if everything isn't perfectly square. And then you're just simply going to work your way down the stairway, cutting one piece after another until you get to the bottom of the stairway and cut your last piece. And that should end up looking something like this. And the last tip I want to provide you with here would be to make sure that all of these materials are finished, including the wall and the stairway. And that's something I like to do. I like to make sure that the wall is textured and painted, or maybe wallpaper is installed, and then install the finished trim over the wallpaper so that I don't end up having such a difficult time painting the trim and cutting it in to make everything look nice. In this video, I will be providing you with a couple of things to consider when building a handrail for a two-step winder. And before I get over to the two-step winder, I just want to point out something that you might not be familiar with when dealing with just a regular landing. And that would be the fact that the handrailing can probably work like this. Because if you're allowed to measure from point to point along a line like this to measure a handrail, and the height from this, if we were going to go straight up vertically, suggests that the handrailing needs to be anywhere between 34 and 38 inches. It needs to fit into that area. It does not specify the top or the bottom, because I sincerely believe most building departments understand that installing grippable handrails on certain types of stairs can be difficult. So if we're allowed to use this line here, then why can't we extend it down to here? And this is my argument for this type of design here. And to design the grippable handrail, all I did was used this right here and raised it up 36 inches. But let's not forget, if your inspector does not like this idea here, then you're probably not going to be able to use this design, and it will need to turn down here, somewhere over here. It'll need to come down and then over. Next up, let's go ahead and swing over to the winder, where I'm using the same handrail layout. And I'm not about to suggest that it'll work here, but I just kind of wanted to give you an idea of what it would look like. We're going to come down to here, over, and then over to here and over, just like we had the landing. So you can see right here, we're going to have problems with this measurement here and with these measurements down here. This right here, this section needs to drop down. And that would look something like this right here. So instead of coming down to here, instead of coming down over to here, we're going to be dropping it down in 2 points, this one here and this one here, to create a design that would look like that. And something like this should pass your building code. All of these measurements would be right where they need to be, as long as one of the starting points fell between 34 and 38 inches, if that's the code for your area. And let's go ahead and put the stairs back in. Now pay attention here, because if I go from point to point and point to point here, instead of dropping down like we're doing down here, I'm using this point on the tread, this point here, and this point here. So why couldn't I use this point here and this point here, even though my hand railing might not work? So again, this one works just fine. If I go ahead and go from point to point or point to point, I'm going to have a problem in this area. I would imagine from about here and the same over here. But again, my argument is, if I'm going from point to point all the way up here, then why can't I do it over here? And that's going to be an argument that you're going to have with your building inspector or your local building and safety engineers in your area. Next up, let's take a look at this intersection here, even though I am not providing handrailing information for the inside of the winder stairs, because some places still allow the winder to be built like this, while others require a 6-inch minimum measurement for the stair steps. So you can see where this design right here is going to produce a little longer line. And I would imagine the longer the line here, the better your chances would be to meet the building codes. And hopefully that makes sense. If it doesn't, or I went overboard and it made too much sense, then feel free to keep it to yourself or let us know in the comment area. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.